I asked you to read this article all here, children. So you must have seen that if there is a circle and we want to draw tangent to that circle. So if the point is inside the circle, no tangent can be drawn. Okay, it will always cut through it. And then if there is any point on the circle, mentioned point, so wahan se one and only one tangent can be drawn. And if the point is lying somewhere outside, okay, then from that outside point, at a time we can draw two tangents to that given circle. Okay, so two tangents possible from an external point. That is an important fact to be kept in mind. Okay, next is now when we talk about length of the tangent. All right, now this is a line, you can't really evaluate this because tangent is a line is indefinite. But when it is from an external point, when I say length of tangent from an external point, then yes, we can measure it, because it would be then the length from the point to the point of contact. Okay, so your PT1 and PT2, these two lengths, and the theorem saying that these two lengths will always be equal. You must have seen the theorem's proof as well. Okay, that very important theorem. First was that radius is always perpendicular to the tangent. Next important theorem, that the tangents from an external point are always equal. Okay, the proof is also very simple. You must have seen that. So we'll consider a circle with center O, external point P, touching and let P, Q and PR be the two tangents touching the circle at point Q and R. Then you're going to join this OQ, OR and OP. All three lengths will be joined, and then you'll get these two triangles which easily come out to be congruent. OQ will be equal to OR, radii of the same circle, OP, common side, and angle OQP, ORP, 90 each, radius perpendicular to the tangent. So RHS मिल जा रहा है हमें in these two triangles, and they are coming out to be congruent. So by CPCT, the remaining portions, that is PQ, is equal to PR. Hence the proof that tangents from external point to a circle are always equal in length. Important theorem. Okay, so isko bhi aap pair up kar lena. Okay, that proof also comes for, they ask you for proving that. Then after that, children, go through these solved examples given here, number of solved examples. Again and again I keep saying that read through the solved examples, children, and this time the probability is more that they'll give you the questions from solved examples. I feel that way. Okay, because they will think कि ये बच्चों के लिए easy approach है, already solved solutions हर किसी को दिख रहा है, तो they'll try to pick up questions from here. So you all read through the examples. कुछ नहीं समझ में आता है, ask me. All right, now we'll start off with 10.2. So simple questions. They are first few multiple choice questions, and children, there is this circular also going around saying that maybe multiple choice question will be increased for your board exam as well. Okay, so we don't know, let's see what happens, but yes, we have to practice multiple choice. So here there's a question saying that from a point Q, length of tangent to a circle is 24 centimeters, and the distance of this point Q from the center is 25. So here I have drawn a figure for that. This is a circle with center O, some point Q, which is 25 centimeters from the center, it was said, and the length of the tangent. So if QP is the tangent, so this length is 24. They are asking you to find the radius of this. That means OP निकालना है आपको. Get the question? Okay. So we know already that OP is perpendicular to PQ, radius is perpendicular to the tangent. तो ये right angle triangle बन गया, तो इसमें Pythagoras theorem लग जाएगा. Okay. So OP being perpendicular to PQ, because of the theorem, by Pythagoras theorem, we can say hypotenuse is your OQ square will be equal to OP square plus PQ square. Okay. So we had to find OP. Here put the values. This is given as 25. This has 24. ये 24 हम इधर ले जाएंगे क्योंकि हमें OP निकालना है. So OP square will be 25 square minus 24 square. Okay, आप चाहो तो squares खोल के minus करके फिर under root निकाल सकते हो, but for calculation convenience, children, this identity really helps us. Like this was a square minus b square form, so I have applied a plus b, a minus b. 25 minus 24 is 1. 25 plus 24 is 49. So 49 is square of 7. So under root करने में OP is 7. Hence the radius is 7. That was your option A here. Okay, now for the next question, figure is given to you here. This figure shown. Then in this, if TP and TQ are two tangents to the circle with center O and angle POQ is given to you as 110, you have to find angle PTQ. PTQ, this leftover angle. ये दो angles आपको पता है, 90 each, radius perpendicular to the tangent. Theorem लगा? Okay. So we would say OPTQ is a quadrilateral. It is a four-sided figure. That's a quadrilateral there. Okay. So in this quadrilateral, these two angles are 90 each because we know radius is perpendicular to the tangent. So sum of four angles of a quadrilateral is 360. So summing up all the four angles, 110 given था, ये 90 है, ये 90 है, ये हमें निकालना है. So this is the equation you get. Hence angle PTQ is 360 minus इनका sum. इनका sum आएगा 0, 0, 0, 9, 9, 18 and 1, 19, 1 carry over, 1 plus 1, 2. So that is 70. That is your option B. Now for the third one, they are saying that if tangent PAPB from a point P to a circle with the center O are inclined with each other at an angle of 80 degrees, then find angle POA. So PA and PB are two tangents. PA and PB, two tangents drawn from an external point to a circle with center O, and they are inclined at an angle of 80. तो इन दोनों जो tangents हैं इनके बीच का angle 80 given है. Okay, so two tangents inclined at an angle of 80 drawn to a circle. Then they are asking you to find angle POA. So you will join PO. This is the angle that they are asking you to find. तो अभी theorem के proof में हमने देखा था कि these two triangles that we get out here are easily congruent. Okay, so we are using that fact. We are saying that triangle OAP and OBP are congruent by RHS. अभी ऊपर theorem के proof में मैंने दिखाया था. Common side, radii of the same circle, 90 each, RHS से. ठीक है. So अगर ये congruent है, इनके सारे angles equal होंगे, तो ये this angle will be equal to this. तो ये total 80 था, तो ये 40-40 each में split हो गया. Okay. So now if you focus on one triangle, आपको ये angle निकालना था, तो हमने ये angle choose कर लिया है. In triangle PAO now, by angle sum property, we are saying angle POA that we have to take out, plus this angle will be 90 because radius and tangent are perpendicular, and this angle is 40. Okay, this I have explained you here कि दोनों angles equal होंगे क्योंकि ये triangles congruent थे, तो 40 each हो गया. All right, so therefore this leftover angle will be 50 degrees.